Hello, it is November 2nd, 2023. Today we are doing count nodes equal to average of subtree. And the problem is asking us to count the number of nodes that match the average of the values of the subtree. So in this example, we take 4, right? We take the sum of all the subtree elements. So we do 4 plus 8 plus 5 plus 0 plus 1 plus 6. And that sums up to 24, I believe. And then you divide it by 6 because there are 6 nodes here. And 24 divided by 6 is 4. So that's why 4 is a valid element, and it contributes to the counter. 5 contributes to the counter as well because 5 plus 6 is 11. 11 divided by 2, you floor that, so it's 10. Oh, no. 11 divided by 2 is 5. And that's why 5. 6 as well because it has no children. It's good on its own. 0 and 1 for the same reason. 8 doesn't work because 8 plus 0 plus 1 divided by 3 is not 8. So let's take a look at the code solution. I'm going to zoom in a little more. Here we go. So we have a counter variable in the class, and we this is the recursive function that goes through all the subtrees, and it's post order, which is interesting because I haven't done post order traversals before. I don't think I have, but anyways, we have a base case. We check the left subtree, and this will return us the sum of values and the number of nodes of the left subtree. We do the same for the right here. And what we do is we add all the values from the left subtree, the right subtree, and the current node. Now we are finally looking at the current node. This is what post order means. You look at the current node after looking at the left and right subtrees. And we get the number of nodes from index 1 of the array. You can see right here. And we could do the important math. We get the sum divided by the number of nodes, and we check if it's equal to the current value. And if it is, we increase the count by 1. And we continue the recursion. We pass on the sum of values and the number of nodes. And in the main function, we just run the function, it updates the counter, and we just return the counter. Pretty simple. I didn't come up with this. I was struggling with, I couldn't wrap my head around the post order and the recursion, so that's where I fell into trouble today. Hopefully tomorrow we bounce back, and yeah, a little bit more talking. This was forced upon me today. This one, without doing it, I couldn't access any other tabs in my browser. So during my discrete lab, I had to use Bing. Is that what it's called? Isn't it Microsoft Edge? I had to use Microsoft Edge at school because I couldn't use this browser because of this Chrome extension. And yeah, but for this one, let's go through it real quick. It's about long division. You have a numerator, denominator, you return the string, but if it has a repetition, like 4 divided by 333, you have to put a parentheses around the repeating value. And to do this, you need to check the remainder every time. That's why we have a map here. And what we do here is, if it already exists, then we want to, the long is the remainder, the integer is the index where the thing starts, the remainder repetition starts. And what we do is we get the position, which is the integer here. We get the position, we insert a parentheses at the position, and we add another parentheses, and then we return the answer. And if we don't encounter a repetition, we just keep on dividing and putting the remainders into the remainder map, we multiply the remainder by 10, so we could keep on dividing it. And it goes on and on and on until it is done. Well, until remainder equals 0, in which case we return the string. And this is my first time using string builder, I think. Oh yeah, and also, interestingly, they used. Oh yeah, I had to search this one up as well. I was struggling with it because of all the PTSD of long division from high school. But pretty much the important part. Well, this is important, but this is not the main part. The person also checked if it was negative, in which case you add the negative number, and then you take the absolute value so you don't mess up any of the division back here later, and that's that. Thank you for watching today. I'll see you tomorrow.